Good morning, guys. How are you doing? I'm going to do a quick little rundown of atomic structure ions. I'm going to keep this short and sweet because I've got somewhere to go, and I feel like you should know most of this stuff by now, okay? So I hate it when it does that. We're going to look at atoms, right? Electrically neutral, right? Electrically neutral. That means that the number of protons, which are positively charged, are equal to the number of electrons, which are negatively charged. Simple as that, guys. That's simple. All right. Notice or note that atoms can have multiple isotopes. It's going to be same atom, right? Different numbers of neutrons, right? Because they have different numbers of neutrons, they have different masses, right? I'll probably remake this video better when I have more time, different mass numbers, okay? Let's look at what some of these isotopes might look like. Some isotopic notation, say. I could have the carbon 12 isotope. I could have the carbon 13 isotope. I could have the carbon 14 isotope, right? These are my mass numbers. These are not my average atomic mass numbers. These are my mass numbers. Symbol dash a number, the number is the mass number. Well, these are all carbon, so they have 6 protons because anything that's carbon has to have 6 protons, period. Mass minus protons, this guy has 6 neutrons. Mass minus protons, this guy has 7 neutrons. Mass minus protons, this guy has 8 neutrons. All right. Another way I could write this would be carbon 12, 6. Carbon 13, 6. Carbon 14, 6. I think it actually goes that way. I can tell you. Yeah, I think that looks more correct to me. Those things are not, we're too worried about that. Okay. Oh my gosh, you can't see it. There you go. You should be aware of that. Now there. Okay. Now atoms often turn into something that we call ions, right? An ion is an atom that is no longer neutral. And by neutral, I mean electrically neutral, no longer electrically neutral. So we can't call it an atom anymore because atoms themselves are electrically neutral. But this is no longer electrically neutral. So we call it an ion. We cannot call it an atom anymore. It is now an ion. Okay? So because it's an ion, it is electrically charged. Remember, atoms were electrically neutral. Ions are electrically charged. All right. That means that the number of protons no longer equals the number of electrons, right? Because if they did, the positives would equal the negatives and they would be neutral. But they are not neutral. So the positives, right, don't equal the number of negatives. Okay. Well, if an atom turns into an ion, it can't change the number of protons because that would change the atom's identity itself. And that's not what's happening here. We just have atoms that are no longer neutral. So now they're ions. So we've got 2 types of ions. We've got cations and we've got anions, right? A cation is a positive ion. An anion is a negative ion. Easy to remember, the T looks like a positive sign. In order to form a positive ion, it can't be, right? If you're positive, that means you have more protons than electrons, all right? If you're negative, it's because you have we have less protons than electrons, right? That should make sense if you're at this stage in your chemistry career, right? what I'm saying, right? If we have more positives than negatives, then we are overall positively charged. Here we have more negatives than positives, so we're overall negatively charged. Okay, well, how does an atom turn into a cation? It loses electrons. Losing electrons, right? It's not by gaining protons, because then we'd have a different atom, because we'd be changing our atomic number. But when an atom loses electrons, it becomes positive. We call it is now an ion, and we call that a cation, right? These are going to be your metals. Metals, oops, that's not very effective, right? This is going to occur with metals or elements with low electronegativities, right? We'll talk more about electronegativities. I'm sorry, electronegativities, all right? It's going to happen with metals or other elements that have very low electronegativities. They're going to easily lose their electrons. Your anions are formed by gaining electrons, all right? And they therefore have more electrons than protons. They are now negatively charged overall. And this occurs with nonmetals, because it just so happens that nonmetals have high electronegativities. They have high attractions for electrons, and we will definitely get into why, but not in this video. Electronegativities, okay? And that is going to do for that, all right? If you have questions, write them down, and feel free to ask in class as soon as possible. All right, I'll see you later.